Hi everybody, this is Mrs. Ellsworth, and today we're going to be talking about the surface area of prisms. And the prism may be a triangular based prism, or it could be like this one, a rectangular based prism. If you're looking for more information for this type of problem right here, they're also called cuboids. On the internet you could look up more information on them. But in Minnesota we pretty much call this a rectangular based prism. Okay, so you'll notice that this side height right here is 8 centimeters, and same thing goes for the other sides. Sometimes I think it's kind of nifty to write these on each one so that you don't mistake it for another measurement. And so it helps it make it a little bit easier for you to see what the side lengths of each side of a rectangle is. Okay, and then also let's look at this another way too. We know that there is two sides to this box, right? So there they are. And that this was, again, it was an 5 by 8, or an 8 by 5 we can call it. I'm going to put on that one. Okay, and then there is a front and a back, and those two are identical too. It was a 9 by 8, 9 by 8. So I'll go ahead and do that. Let's use that number there, and an 8. Okay, and it's identical to the back. Okay, so there's two of those sides. And now I've got so many measurements here. Let's get some of these out of here. Okay, and we've got two of these here, and they are a 9 by 5. Okay, and so you can see that you've got two of those, each one of them, a top and a bottom, front and a back, and a side and a side. Okay, and I know that you've seen these written some other ways too from your previous year here at school. Okay, now notice that we've got a 5 by 8 here. The purple is a 5 by 8. Okay, and the blue one is an 8 by 9. Okay, and the orange one is a, let's see, that'd be a 9 right there also, a 9 by, and then this length right here is also a 5. Okay, and that, of course, you've got two that are the blue color here, and the two that are the purple, and two that are the orange, just like what we were talking about on the other page too. And we can also go and do some figuring out here. We know that this side right here is the 8 by 5, and it is 40. Oopsie. It is 40. Okay. And we know that this one right here was the 9 by 5, and it was 45. And these are all in square centimeters. You know, centimeter times a centimeter equals square centimeters. I should have wrote that out. Then you add them all up. Okay, so like you can go and calculate 45, 45, 72, 72, 40, and 40, and you can figure out the surface area of it. Okay, the surface area again is like painting the outside of a cube. Where is that paint touching at? Or if I was going to make a box this shape, how much cardboard would I use? And so these nets here show that all spread out. Okay, and I know you've seen those before. I do it a little bit different. I do it the Ellsworth way. I just recognize that, hey, here are those sides again, and that we've got a top and a bottom, they're identical. We've also got two sides that are identical, and we've got a front and a back that are identical too. So, oh, I just said that pretty much. So what I do basically is I figure out, well, hey, this front side right here is going to be 72 square centimeters. So I, draw out the picture, and I just pretty much just write it on there. And then the top and the bottom are going to be 45 square centimeters. This is a 9 by 5. Okay, and the side there is just the 40 square centimeters. So what I really do is I just put them on the three sides, because in every one of these problems I show you three sides. The three sides that I see that are facing me, I go and I put the numbers on there, and then I recognize I just got to add them up and multiply by 2. Okay, I just have to add them up and multiply by 2. So here's what I did. I would figure out a side. Okay, let's go ahead and put that in there. I'd figure out a side. Okay, and I know my sides are 42 square centimeters. I know my front is 72 square centimeters. And I know that I've got a 45 square centimeters there too. And I just add them up. And I multiply by 2. So again, I put the numbers on the sides that I see that are facing me on the box. There are the three sides. and I'm multiplying by 2 because, of course, you got a front and back, top and a bottom, side by side. And when I do that, I still get 314 square centimeters. You would have gotten that way if you had taken your different sides and added them all up this way too. If you'd figured out each one of those and just added them all up, you would have gotten the 314 square centimeters also. Okay, so I try to show you more than one way of doing it. You decide how your brain likes to think and you use that information. Okay, let's look at this one. This is like a cereal box or like a garment box that you get for garments for presents from stores and stuff like that. They're flat. Okay, there's only 1.7 feet tall. Those ones I'm thinking about are only like 1.7 inches tall. Anyway, so it's very, very short, okay, height. And again, it doesn't hurt to write them all out. And then this side is a 6.4, 6.4, and then your long lengths are going to be the 12 feet. Okay, so I just wanted to show that, just to remind you that it doesn't hurt to go and draw these things out and write the numbers on all the sides. Okay, and so you've got 5 through 8 here that is due, and okay, and then let's look at triangular prisms. Okay, and I believe that you've got 13, 14, and 15 that is also due. Let's just go and look at 13 first. Okay, on 13, notice that this is kind of like a net of it too that I'm showing here. We've got 2 bases, 2 triangular base bases. Okay, we've got 2 of those. But let's look at these lengths right here. Okay, we've got a 14, and we've got 10, and we've got 24. Oops, that is not right. It's a 17.2. Okay. All of these right here are the sides to the triangles. Okay, that original triangle, this is a 14, a 10, and a 17.2. 14, 10, and 17.2. Okay, so we're pretty much looking at a net again. Okay, we're pretty much looking at a net again, so you can figure out the area of each one of these. Okay, and I've got that figured out for us. Okay, and so you go and what's the area of a triangle? It's base times height divided by 2, so that's 70. This right here is base times height divided by 2, and that's 70. Notice I could have not divided by 2 because here I have to go and multiply these by 2, the 70 by 2, or else, I mean, you can figure it out that way too, or else you can just figure out each one. Okay, and here is each area also. Now notice something else about this. So that's one way that you could do this, like a net. Okay. You can also look at it another way. I kind of like this. I think it's kind of cool. So before we had that this is 14 and 10 and 17.2. Now if I would go and notice that these again are the 3 sides right here. If I would go and add them up, I would get a 41.2. So I could look at this as one big huge rectangle. Okay, and that is the perimeter of this thing. It's right here, 41.2, and then times the height of the whole rectangle here. The whole thing is 24. Each one of these before in the previous pane. Okay, did you see that they're all oops, right here, that they're all 24 for their height each time. Okay, and so you could also do it as perimeter. So it's perimeter, which is the 41.2 times the height of this whole thing, and then you can figure out the area of this rectangle. So when you do that, here it is, perimeter times height. Now you just need to add up 2 of your bases. Okay, and 2 times the base, the area of this base, which was 70, and then you're going to still get the same exact number, the 1,128.8 square centimeters. So it's just one more way of looking at this one. And you can do that with these ones too. You could figure out the perimeter. Let's have the perimeter, the base be right here. Okay. And so you could figure out the perimeter be 8 plus 5 plus 8 plus 5. That would be your perimeter. The height of the whole thing would be right here, because you could open that up to one big huge rectangle. Here's a perimeter and then that height. And then you've still got 2 bases, so you have to take the 8 times 5 times 2. You'll still get the same number that we got on the front side there too. Okay, so you can use this one for surface area of prisms. Okay, in your homework you're going to have, you're going to have 12 and 4 for extra credit. This is just asking for you to paint the fence on both sides. Okay, and so it's not quite a rectangular base prism because you don't have a top and bottom, but you can figure out each side and add it up and times it by 2 because it wants to cover the paint on the inside and the outside of the fence. And then it tells you that 1 gallon covers 350 square feet, so will 8 gallons cover it? Okay, so you can do that one. That's a pretty exciting one. Realistic. Right now we're painting a house, and that's very realistic. Here's another one. Number 4 was extra credit. Notice that this is an isosceles triangle. Okay, and this isosceles triangle has got a 15 and a 15 for this one, and that's got that right angle there. So this is the base and the height of the triangle for when you figure out the area of this base. So this one's only just figuring out for the area of that rectangle that's on the bottom, so watch out for that one. So extra credit is 4 and 12. You have 7 problems to do. I did 5 and 13 for you. And use whatever method that makes sense for your brain the best. And because not everybody sees things three-dimensional real well. So it doesn't hurt to take out an object that's got the same shape. At home, it's kind of hard to find these ones, and or else you could even cut out, take a piece of paper and fold it, you know, in 3 folds, and you could see that shape right there. Okay, so I will let you go, and I will see you later. Bye-bye.